So into the science now. Why is it important that this is visual? I found this quite interesting infographic now that the average human attention span has actually reduced from 12 seconds down to 8 seconds, which is now lower than that of a goldfish. I assume that is mainly due to the proliferation of things like smartphones, things like videos, the constant access to being able to scroll down social media, being able to look at videos and so on. So visual captures the attention in a much quicker and a much better way than if it's not visual, if it's in a table, for example, or if it's not clean, if it's cluttered. Looking at something a little bit like looking at a piece of art, if you're looking at something that is satisfying, then it's more likely to capture attention for a longer period of time. And this really comes onto the topic of encoding. So by making data visual, so in this case, the data here is the text that I've given. I've made 2 bits more visual, they stand out. We've got the use of italics here, we've got the use of bold, we've got the use of color. So encoding data with various properties, and we'll come on to some of the properties that you can actually encode your data with, can make it really stand out so that you're capturing the attention of whoever your audience is going to be. And that's, again, this is the visual aspect, and it allows us to turn tables of numbers, lots and lots of data into something that is quickly digestible. So we're going to do a little test now. If you can prepare your poll, Matthias. I'm sure many of you who have been on any kind of data visualization will have seen something similar to this, but we're going to do this quick test and then we're going to dive into it a little bit deeper. So first off, I'm going to pop to the next screen and I would like you to count the number of 9s in my grid. There you go.
Poll is launched.
Thank you very much. We won't have very long here. There we go. So if everyone is able to go over to the poll, count how many 9s there was, and we'll check out the results. So everyone can have a little bit of time to answer this, but how many 9s did you see in that grid? In the meantime, you can have a look at Ron Burgundy there.
40% voted.
Okay.
Almost half of the people voted.
I think maybe a few people were a little nervous. This is an anonymous vote, so you can put whatever you want. No one's checking, no one's counting. You won't be marked on this.
10 more seconds, then we'll have a minute. Okay, closing the poll.
Are we looking? Okay, so it's a pretty widespread there. Most people have answered 9. Interesting. What's second after that? It's 5. So 9 or 5. So maybe they're kind of at the extremities of either side. I know it wasn't on the screen for very long, but that really supports my point. So majority said 9. I'm now going to flick this up. Very quickly added some color to my graph, and now suddenly the 9s are popping out more. And within a second or so, you can calculate how many 9s there are. So for whoever said 8 was the number, there are 8 9s in my grid. So what exactly just happened there? This is what's called the sensory memory. This is the part in your brain that identifies something before you're even conscious that you're doing it. It's looking at something, and if something is different, so in the previous case that we had, it was the 9s that were colored in red. They popped out from the rest of the gray, and so all of a sudden you're able to very quickly use your sensory memory to focus on those 9s and count them a lot more quickly than in the previous grid. So it's this part of the sensory memory that really drives the attention of your short-term memory. So we'll go into exactly what that is. But before that, I've seen that given in a lot of presentations, the gridded number, and I think there is a little bit further that we can go with it. So don't worry, I'm not going to make you count anything in here. Here is another much larger grid of numbers. I think it's 15 by 15. So let's say in a hypothetical world, we're looking at analyzing this set of numbers, finding out how much there is of each. First step, maybe I did exactly the same as I did last time. Again, looking for the number of 9s. And because it's quite a bit of a larger grid, it's less easy now to focus, and it might also be something to do with the colors I've used here, so the orange and blue. The 9s stand out less in this grid than they did when we were looking at the reds and the grays in the previous one. So what can I do about that? Maybe instead of using just the color of the number, I can use the color of the square behind them, and all of a sudden that because there's so much more mass behind the color, it becomes really easy to pick out where those 9s are. So again, the short term, the sensory memory is really focusing on the odd ones out. So it's trying to detect a pattern, and it's seeing that there are 2 colors here in this block that are very different to the rest of them. So what if I want to find every single color here? What if I want to find out how many 1s? Instead of, so in this case, I've just applied a unique color to every single number, 1 to 9. And all of a sudden our brain struggles to be able to cope with this amount of data, trying to work out by using color which one has got the most. So quickly, you can see from going from a color palette of just 2 to really drive that sensory memory to a color palette of 9 different colors, all of the same hue, all of the same blue. It makes it much more difficult to try and get anything from this. And so at this point, instead of using the attributes of color to encode our data, we maybe need to think about using something else. So in this case, I have used just a simple histogram. And in this case, the attribute that we're using to encode the data is the length of the bar. So which of these has the tallest bar? That is the most. So there was 33 7s in there. And then there was 30 1s and 2s. But when I returned to this, when I was looking at this, when I was preparing these slides, the number that for some reason popped out to me was 1. I don't know if that is the same case with anyone else, but I think when I was looking at it, it's the lightest color out of all of these. Very quickly, I could see there were patterns in where the 1s were displayed. So in this case, it looks a little bit like a Tetris group of, I don't know, the Tetris shape perhaps. And so 1 appeared to me to be the largest. 7 really faded into the background here. I was surprised to see when I turned it into my histogram that there was more 7s than anything else. So that's a short little talk about how encoding is really important with, you need to think about what you're actually encoding the data with. Sometimes color is fantastic, but quite quickly, even when you get to 4 or 5 different colors, it can become overpowering and you have to shift. And instead of using color, thinking about using something different to visually encode your information. Here is my mobile number. That's actually my home telephone number from a long time ago. But this is now moving on to the short-term memory. So have a look at that. The short-term memory is when we start to capture things that sit in our brain that will stay there, but unless you repeat them a lot of times, they won't be committed to your long-term memory. So in this particular example, our short-term memory is attributing the blue color here to first class. It's switching between the legend and the charts to make the connection. And then if you were to use these colors again in the next slide or in the next dashboard you're making them, that short-term memory is really grasping on the fact that the first class is expected to be blue, and if you're changing those colors, then the memory is expected to unlearn and then relearn what those color palettes are actually being associated with in the short term. So good example of that is, again, returning to our lovely Formula 1 data. Here we've got the same chart as earlier, but with a bit of color applied to it. And we've got Michael Schumacher up there in the top. He's a nice orange. Lewis Hamilton in the blue. Sebastian Vettel in a kind of teal color. So this is all to do with the drivers. We've got a color palette. Our short-term memory is committing the fact that Michael Schumacher is orange to our short-term memory. Lewis Hamilton is blue to our short-term memory. And then when we pop this up, this is a different chart now. This is showing the number of pole positions that they've won. We've maintained that Michael Schumacher is still orange, Lewis Hamilton is still blue. So that connection is there, but if in an hour's time tomorrow, that connection will definitely have disappeared. Blue will no longer mean Lewis Hamilton to you. It will mean something else. So this is how we make use of the short-term memory when you're looking at several charts, perhaps on the same page, making a link between the colors in those charts. It can be a really effective way of allowing the user to quickly grasp there's a connection between those two charts. Some of the sharp-eyed amongst you may notice that there are different colors in these two charts, and this is something that we'll go on to later as a bad practice. So you'll see that just there in the background, Fernando Alonso and Juan Fangio here are both the same brown color, and that is a something that isn't a good idea to do, just because, again, what I mentioned earlier, you're having to unlearn a color and apply it to a new one. So for these top ones, these colors are all the same, and we can quickly move from the blue of Lewis Hamilton to the blue of Lewis Hamilton in the second one. But for some of the other ones where they aren't the same, we are kind of flaunting those best practices. So finally, we've talked about the sensory memory, we've talked about the short-term memory now. Let's talk about the long-term memory. So this is when something that you either learn through repetition, through experience, through something that is prevalent in the culture that you exist in, gets committed to your long-term memory, and you can then draw on that to get context into your visualizations to understand them. So usually when I'm presenting this, it's to a class, and I'll ask people, what does this chart mean to you? What do you get out of it? And especially when I'm presenting it in Europe, it takes quite a while for people to understand what's doing this. There are a couple of visual cues in there to really help the audience, but interestingly, if I'm presenting this to an audience in the US, they are much quicker at getting the answer here. So this chart is showing firework-related hospital events. And the reason that the people in the US get it much more is because of Independence Day. Fireworks are associated with Independence Day. And so they quickly make that link, and they're able to see that, okay, Independence Day is in July. There's a spike in that. They're able to use the visual cues in my graph, the fireworks, the hospital, to make those connections and piece it together much more quickly than to a European audience, where if it's in the UK, they're looking at November. That's bonfire night, where there's traditionally a lot of fireworks in the UK, is on the 5th of November. Perhaps you're looking at December for New Year's Eve, or January even. And so if the graph is showing something different, it's then pulling on your shared frame of reference, your contextual knowledge of a country or traditional norms or culture to piece together what that graph is showing. And again, another example of this using Formula One. So it's something that I tend to use a lot in all of my F1 visualizations. For F1 fans, this means a lot more than it does to people that aren't F1 fans, but even for those that don't follow the sports, the color red is associated with Ferrari. Red Ferrari is very, very glamorous, very chic. In motorsport, these are the racing colors currently of the various teams in Formula One. So that teal is associated with Mercedes, and again, you're drawing on your long-term memory, your knowledge of the sports, or your knowledge of Ferrari being red to make that connection, rather than having to rely necessarily on the legend. So the important thing here is thinking about who your audience is going to be. Are they going to be an audience that shares your shared frame of reference, or are they going to be completely alien to the world? So for any people on the call right now that don't know anything about Formula One, couldn't care less about it, you're going to be thinking, well, this doesn't mean much to me. The orange McLaren doesn't mean much to me. Maybe you'll get the Ferrari red, because even outside of the world of Formula One, you have cars Ferraris that tend to be red. But I'm relying on the fact that there will be other people out there that are interested in Formula One that really make that connection, that association. So if you're doing this on a particular topic that you know that the audience is going to know what a particular color means automatically straight away, then use that to your advantage. If you're not sure, or if you know that your audience isn't going to have that connection, then you just have to be cognizant of that and maybe use colors that don't automatically mean something. But we'll do a bit more of a deep dive into color in a little bit. And you'll see that in this particular one, coming back to the piece that I did earlier, that is used throughout here. We've got the red of Ferrari, meaning the red every time. We're also using things like flags here to be put into the long-term memory. So in these two bottom sections, we're using the British flag, the Italian flag, the German flag, French flag to symbolize, and people recognize flags, and without having to zoom in, they can automatically recognize that that belongs to a particular country. Same here with things like the grid layouts. That's something that is very prevalent in Formula One. The little graph that represents the engines, all of this is kind of designed to make someone feel like they are engaged with the topic, and they're looking at it and they're thinking about the design of it, and then able to get to the information and understand all the statistics behind it as well. Final little piece in this section, something called cognitive load. So this is where the brain is trying to process things. The best example I can think of this is when you're driving a car, and there's a really good book, Thinking Fast and Slow, which talks about what the brain is doing, how it's thinking, and whether you can undergo maths problems while you're driving, if your concentration loses, and it actually focuses on pupils dilating to work out how hard you're concentrating to achieve a particular task. So thinking about driving, 50% of our concentration span is taken up while we're driving. Yeah, we can still listen to the radio and engage the radio. Perhaps we are on voice call to a friend, to family, and so on. And then obviously that changes depending on the weather conditions. So if it's stormy, whether it's cloudy, then it becomes much more difficult to concentrate on whatever's going on in the back seats. Or if there is, if you're trying to have a call with someone, it becomes much more difficult to concentrate on that. And exactly the same concept applies to when you're visualizing data. If you try and overload something, so here is an example where we've dropped this is the sales data, we've dropped the subcategory and the city onto the various marks attributes. So one of them on color, one of them onto city. And all of a sudden it looks extremely crowded. Our brain can't quickly commit to the short-term memory what each of these different things mean. So it's worth thinking when you're designing visualizations like this, things like shapes, things like color, all place a strain on the brain to a certain degree. Now, you can use it to your advantage by making it fairly minimalist, not having to work on exactly, on having to decipher lots and lots of different things, but always be conscious not to put too many things into your visualizations. Otherwise, people are going to start to become overpowered and not be able to focus on exactly what's going on. Finally, two audiences of visual analytics. The first one is you, and this goes back to what I was saying about the flow of visual analytics. You as the analyst, you receive a data set, you are set a particular task, or you've got a hypothesis to answer. You're now diving through that data set, answering the questions, finding new questions, and you are the audience of that. And by changing the data and by changing the chart types and the attributes of that data, you are getting answers out of that visual analytics. But once you've done that, you then want to present that to someone. You want to share your findings, you want to share the research that you've done and the questions that you've answered. And therefore, the second audience of visual analytics is everyone else, the people that will be viewing your research and the reports and the dashboards that you're creating. So visual analytics is used in the first case to help you answer your own questions, but then it switches and it becomes the responsibility of you as the analyst, as the person that's creating the visualization, to use visual analytics to your advantage, to your benefit, to really allow the audience to tap into to what they need to see. So perhaps you want to use color, perhaps you want to use a certain shape to really focus the eye of the audience. But it's an important point that there's two audiences, yourself and then the people that are going to be viewing your work afterwards.